discussion is inequations. Okay, inequation actually means which is not an equation. Okay, so two things to remember in mind when you're going to solve the inequations. First and foremost thing is that keep x always positive side. Okay, that means make sure that x is always positive. Okay, suppose if x is on the left hand side of the equation and is negative, transfer to the right hand side, and if x is negative on the right hand side, shift it on the left hand side. Okay, and second thing is that don't change the sign given. Okay, the sign given means whatever it is, less than, greater than, or equal to, whatever is given, you don't change the sign. Now let us do one question. Solving the method of inequations, whether x belongs to rational numbers, real numbers, whole numbers, natural numbers, the method of solving an equation is same. Okay, now before that, let us know what are integers. Integers also represented by I or Z. Okay, these indicate a set of numbers, positive and negative, connected by equal to sign. Suppose we have dot dot dot, -3, -2, -1, 0, then we have 1, 2, 3, positive dot dot dot. So you can see 0 is the element that connects set of positive integers, set of negative integers. Okay, so when we write z plus, that means it indicates positive integers. Okay, under this we include the numbers coming after 0, that is 1, 2, 3, like that. If z minus is there, okay, it indicates negative integers. Okay, that means the numbers coming left of 0, -1, -2, -3. So integers are represented by I or Z. Second, then we have the natural numbers. Okay, these numbers are represented by n and they start from 1, 2, 3, 4, dot dot dot. Okay, then we have a set of whole numbers which are represented by the letter W. This is equals to, it starts from 0, that's the only difference between the natural numbers and whole numbers, then 1, 2, 3, 4, dot dot dot. Okay, then we have the real numbers, okay, which are represented by R. Okay, these are not having absolute values, as you can see. They are represented as a set builder form. Say for example, x is greater than equals to -2, less than 3. Okay, so there could be numbers ranging between this. These are the lower limits and upper limits, and the numbers satisfying the real numbers come in this range. They could be fractions, they could be decimals, they could be numbers, perfect numbers. So for these numbers, integers, okay, that means right from here to here, we can represent this by absolute numbers, and when you plot the number line for this, they will be represented by dots. You don't have to join them. But in case of real numbers, you can't write the truth set. Truth set means the elements that can be represented by commas, separating commas. Okay, suppose we have a range, x is greater than -2, less than 7, 1/7. And the replacement set says that x belongs to whole numbers. Okay, then the truth set for this will be, because it belongs to whole numbers, it starts from 0, so you write 0, then 1, 2, 3, 4, 5, 6 and 7. Okay, because it is less than 7, 1/7, so you can't write more than 7. Similarly, the same okay? If it belongs to natural numbers, then the truth set, that means the element satisfying this inequation will be, it will start from 1 because natural numbers start from 1 as you can see. So 1, 2, 3, 4, 5, 6, 7, that's it. If I say the same statement holds truth for the integers, natural numbers, whole numbers, okay, then for integers it will be x belongs to, suppose integers, then the elements of x satisfying this will be, because x is greater than minus 2, we shall write minus 1, because greater than minus 2, minus 1 will start. So minus 1, then 0, then 1, 2, 3, 4, 5, 6, 7, okay. But if suppose the same statement holds truth for the real numbers, suppose the replacement set is x belongs to R for this, okay, then we cannot write the truth set for this, okay. We have to leave it as it is. That means x is greater than minus 2, less than 7, 1 by 7, okay. So for R, x belongs to R, we cannot write the truth set, okay. But the plotting will be different for this and these three, okay. For all these three, the number line plotting, okay, that means when you are taking the number line, please give equal space for all the numbers which you are giving. So this is the range, suppose, okay. Now for the first three, that means x belongs to whole numbers, x belongs to natural numbers, x belongs to integers, you have to put in dots. Suppose for the first we write x belongs to whole numbers. So you place one dot over here, 0, 1, 2, 3, 4, 5, 6, 7. But don't join them, right? The same will be truth for this, this and this, okay. For integers, you have to write all the dots on these numbers on the number line. But for R, okay, the plotting will be different, okay. For this statement, we shall take a number line. This is minus 2, suppose, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, okay. Since the number says that x is greater than minus 2, so we shall write here, because x is greater than minus 2, we shall put a ring over here. Ring means the numbers are not equal to that, but they are either less than or greater than that. Next, the upper limit says that x is less than 7 by 7. Now here, you have to do one thing. See, between 7 and 8, okay, you leave the gaps same as this, okay, only for this question I am saying. Suppose this is minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, okay. Now, x is greater than minus 2, put a ring over here, okay, and x is less than 7 by 7. Now, between 7 and 8, you have to show 7 parts, whatever the denominator says. And for that, the markings, what you are going to make will be 1 less than that. Suppose you have to do 7 parts. Show 6 markings, equally spaced. Start 1, 2, 3, 4, 5, 6. Okay. Now the number what you want to represent, 7 by 7, is here. After 7, the first number, this is 7 1 by 7, okay. Now because x is less than 7 by 7, you can put one ring over here, okay. Then please highlight this, okay. This has to be highlighted as I am highlighting this, okay, up to here. Don't enter inside the ring, okay. So this is the number line plotting, the continuous plotting which is to be shown only in case of R, x belongs to R, okay. Like this you have to highlight, okay. But the joining is not to be done in case of x belongs to whole numbers, natural numbers, integers. You have to put only dots but don't join them. Let's take one more question. Suppose we have x is greater than equals to 2 1 by 2 less than 5 1 by 3. Okay, and it says that x belongs to R. This you have to plot it. Now this is your number line. So this is suppose 1, 2, 3, 4, 5, 6, 7. Okay. Now since x is greater than 2 1 by 2, you have to show two parts. For that the number of markings will be 1 less. For 2 parts you have to show 1 marking. For 3 parts you have to show 2 markings. For 4 parts you have to show 3 markings. So here 1 marking I have seen. Okay. So already there are 2 parts. You can see it. 5 1 by 3 means for 3 parts you have to show 2 markings equally spaced. 1, 2. So this is 5 1 by 3. Please highlight this. Okay. And 2 1 by 2 is this one between 2 and 3. Okay. Now what you have to do? Since x is greater than equals to 2, so put a dot over here. Why dot? You know, because the values of x are equal to and greater than 2 1 by 2. Since it is equal to, so you have to put a ring and dot. So this is the dot. Okay. Now here the right hand upper limit says x is less than 5 1 by 3. So here since it is not equal to 5 1 by 3, you have to put a ring over here. Okay. Then join it. So please highlight this because x belongs to real numbers. So this is the way you have to plot the number line. Okay. Now let's come to solving part. Okay. We are taking one question. How to solve the inequation? As regards plotting, I think it is very clear to you. Okay. Now let us take one example. Suppose we have a question over here. Minus 2 2 by 3 okay is less than equals to x plus 1 by 3, which is less than 3 plus 1 by 3, and it is given that x belongs to R. You have to solve and plot it on the number line. First and foremost thing, don't forget to use this symbol. This symbol implies, this means implies. So you don't have to put or, equal to, therefore. This is the symbol with which you have to begin this. This whole statement comprises of 2 parts. This is one part, this is one part. Okay. If you solve these 2 parts, you get 2 limits. One is the lower limit, the other is the upper limit. Then from that you can draw the number line. Okay. Now see, we have the first statement minus 2 2 by 3 less than equals to x plus 1/3. As I told you, you are not supposed to change the sign and keep always x positive. So since x is positive on the right hand side, let it remain on the positive side. Shift this 1/3 over here. So converting this into mixed fraction to improper fraction, 3 to 6 twos, it is minus 8 by 3. Okay. Plus 1/3 comes on the left hand side, becomes minus 1/3. Now we have minus 9 by 3 less than equals to x. That means x is greater than equals to minus 3. Okay. So this is the lower limit, right? Now wait for the second part. Again we are taking the second part, that is x plus 1/3 less than 3 plus 1/3. Okay. This implies, because x is on the left hand side, let it be positive. Now shifting this 3 plus 1/3 minus this 1/3. Okay. So these two get cancelled. So we get the upper limit, x is less than 3. Now combining this and this statement, we can write final statement x greater than equals to minus 3 and less than 3. Okay. Now since x belongs to R, we cannot write the truth set for this. Okay. This is called the replacement set. Okay. So for only R, the answer will be x is greater than equals to minus 3 less than 3. Okay. Now as regards plotting, this is suppose -3. Here we have -2, -1, 0, 1, 2, 3, 4. Okay. Since x is greater than -3 and also equal to, put a dot over here. Okay. It is less than 3, put a ring over here. Okay. So the ring and dot concept should be very important when you are plotting the real numbers. Now join this. Please highlight this. Okay. Please see that the line should not penetrate inside the ring and the ring should be clearly highlighted. This is the dot because the values of x are equal to and greater than -3, but since they are less than 3, you cannot use a dot over here. Okay, so this is the method. So the solving method is same for natural numbers, whole numbers, real numbers, integers, but the plotting is different. We are using dots without joining for natural numbers, integers, whole numbers, but only for real numbers we are using this number line continuous plotting, and wherever you plot the lower limit, higher limit, they should be linked up by a bold line. Okay, so please highlight this line. It should be more bold compared to the line what you are showing to hold the number line. Okay, so this is about inequations. Okay, now let us take one question, problem solving question. The problem solving question. Now students, let us take a problem sum based on the inequations. The problem sum is that we have to frame the inequation first and then solve it. Okay. Now the question says find the greatest integer, okay, which is such that if 7 is added to, okay, if 7 is added to double the number, double the integer, okay, the resulting number is greater than 3 times the integer. Okay, that means you have to find the greatest integer which is such that if 7 is added to double the integer, okay, the resulting number is greater than 3 times the integer. Let the integer be x. Okay, now when you adding to 7 to double the integer, okay, 7 added to double the integer. So what do you get the resulting number? This is 7 added to double the integer, right? Now as per question, the resulting number, this is greater than 3 times the integer, right? So let's read the question first. Find the greatest integer, that we have taken x, added to 7 to double the number, that means 7 plus double the integer, okay? The resulting number is greater than 3 times the integer. Now when you solve this equation, the number 2x shift on the right hand side because x has to be positive always. This means 7 is greater than x. That means because we have taken integers, so you have to write the integers which satisfy this statement. X less than 7 means you are going to write 6, 5, 4, 3, 2, ... Okay. because integers come on the negative way also. Now since you have to pick up the biggest integer, okay, among the list, so the value of x will be 6. Okay, so among the list that satisfies the inequation as per the question, this is the biggest integer. So 6 is the biggest integer. Okay, so I hope you have clearly understood this. Okay, now there are some questions in which you have to plot two statements, okay, and you have to solve two equations. Then you have to take a common statement, intersection. Okay, now let us take one question. Suppose we have P is the solution set of the statement that satisfies P is minus 3x plus 4 less than 2x minus 3, and it is saying that x is belonging to the natural numbers. Okay, then Q is the solution set of, for this another statement is given, that is 4x minus 5 less than 12. Okay, and here x belongs to W. Now you have to find, the question says find P intersection Q. Okay, intersection means the elements common to both, and second you have to find Q minus P. So let's solve the inequations first. For P, the solution set is minus 3x plus 4 less than 2x minus 3. This means because x has to be on the positive side, shift minus 3x on the right hand side, so it is 2x plus 3x less than greater than, minus 3 goes over here, so it is 4 plus 3. Now here we have 5x greater than 7, that means x is greater than 7 by 5. That comes to 1, 2 by 5. Okay, now just imagine the natural numbers that satisfy this. Greater than 1, 2 by 5, you can include 2, 3, 4, 5, dot dot dot. Okay, now let's solve the inequation Q. The inequation Q is 4x minus 5 less than 12. This means 4x is less than 12 plus 5. That means 4x is less than 17. This means x is less than 17 by 4 is that x is less than 4, 4 for the 16, 4 ones are 4. Now tell me, if you are given such type of statements, okay, the values of x less than 4 1 by 4 belonging to whole numbers, that means the value of x over here will be 0, 1, 2, 3, 4, right? So these are the values that satisfy the inequation when the replacement set x belongs to whole numbers. Now P intersection Q, the first part, the elements common to P and Q will be, look at this, only 2, 3, 4 are common. So intersection means common elements, so it will be 2, 3, 4. Second part says Q minus P. Okay, Q minus P means from the elements of Q, subtract the elements of P which are common. So if I write 0, 1, 2, 3, 4 minus the elements of P are 2, 3, 4 dot dot dot. So if your elements 2, 3, 4 are cut from this, what is left? Q minus P will be 0, 1. So you might be asked to solve the questions based on this. Okay, I hope this chapter is very clear to all of you. The solving method is same for all the natural numbers, whole numbers, real numbers and integers. Okay, the plotting is only different. It is continuous plotting for real numbers and in terms of dots for natural numbers, whole numbers, integers. Okay, thanks for watching.